Hello everybody, welcome to this video where we are going to discuss about buffering at the transport layer. So we know that the transport layer receives the data from the network layer and provides it to the application layer at the receiver, and at the sender the application sends the data to the transport layer and the transport layer passes it on to the network layer. In between, the rate of transfer between the application layer and the transport layer and application layer and network layer may not be the same. So to keep a balance, the transport layer stores the data that it receives from these layers into its own buffers. So a buffer is nothing but a space, a memory location where these segments will be stored. So let us see some concepts about buffering at the transport layer. So if we look at the sender side, so at the sender, here you have the application layer where you have multiple applications. Say this is application 1, this is application 2, okay? And then there is the interface for the transport layer. So here is the transport layer, okay? So alright, so this is the interface between the transport layer and the application layer, okay? Now when the data is received from the transport layer, from the application layer to the transport layer, it is at the transport layer there are, for each connection there is a buffer and the data is written to the buffer. Similarly, for the second application, for the second connection, data is written into the buffer for the second connection. So the buffer, this is the buffer for app 1, this is the buffer for app 2, okay? Then comes the interface with the network layer. This is the network layer and there is only one point here, so the data from this buffer as well as this buffer has to pass on through the single point and they will go to the lower layers to be transmitted, okay? Now here you see there are two rates, two data flows. One is from the application layer to the transport layer, okay, and the other is from the transport layer to the network layer. So these two, this can be flowing at a particular rate, so let's call it at a data rate 1, and this can be flowing at a different rate. Let me use a different color here, okay? So this is flowing at rate 2. So rate 1 can be higher than rate 2, rate 2 can be higher than rate 1. So it is not that data is being passed on from the application going to the buffer and then the data is going from there, it is going to the network layer, so at the same rate. No. So what happens is that it may happen that this is very fast, this is very fast, so the buffer gets filled up quite fast, okay? And this may be slow, so the buffer is full before the transport layer can transmit to the network layer. So now when the application layer tries to add new data to the buffer here, it finds that the buffer is full. Now one point to understand here is that these read and write operations that the transport application layer performs, so the application layer performs at the sender, it performs write function calls. So basically it is writing to the buffers at the transport layer. So these are implemented, as remember the transport layer is implemented at the OS, at the operating system. So these write function calls for the applications are translated into OS system calls. And because these rates can differ, this buffer can become full. So this write operation, if the buffers are full, then the call is blocked. That means no more data can be written. So this is blocked. The write operation will block this. So it cannot write anymore once the buffer is full. At the receiver, you have just the opposite. You have the network layer. You have the network. This is the network transport communication. So here the data arrives at the network layer. Then it goes to the transport layer. So because these segments will have the port number in it, so depending upon which application that port is running on, which that application is running on which port, there will be different buffers and they will be sent to the buffers. And then at the end you have the applications. At the application layer you have app 1, this is app 2. So now app 1 will read from here, app 2 will read from the second buffer. So here also the rates, that is the rate at which the application layer will read from the buffer and the rate at which the transport network layer will write to the transport layer buffers may be different. So it may happen that the application layer is trying to read something from the buffer, but the buffer is empty. Data has not yet arrived. So here if the buffer is full, there is no problem. This network layer will have to wait. Similarly, if the application layer is trying to read from the buffer and it is empty, then here also the function call that is used is the read function call. So you have the read function call or receive function call. So this is also implemented as a OS system call. So the read function is blocked if the read function, so here it will do a read. So this read function will block if the buffer is empty. If it is empty, then this will be, the read function will block. So, and when new data arrives from the network layer, when new data arrives here, then there will be a system, the operating system will issue an interrupt, something called an interrupt, and this interrupt will wake up this application and then it will unblock the read. So now data can be read by the application layer. So we see that the role of the buffers at the sender as well as at the receiver is very important, because the two rates are different. So buffers are very important to have. Now another thing that is important is that these buffers have to be organized in an efficient way. So there are different organizations of the buffers depending on different scenarios and applications. So let us see some of these organizations. Okay, the first is your fixed sized buffers. Fixed size buffers. So here in fixed size buffers, if all our segments are of the same size or are of similar size. So if segments are of same or similar size, then we can have the buffer can be of fixed size. Each of these buffers can be of same size. Okay, and in one buffer you will have one segment. Every buffer will have one segment, and so on. So this is useful only if your segments are of the same or similar size. If the segments vary in size, in that case this may not be a very good choice. The second is you can have chained fixed size buffer. Chained fixed sized buffer. Okay, now in this case you can just think of this to be an array, this buffers to be arrays. Okay, so one by one, sequential. On the other hand, if it is chained, you can think of this to be the buffers to be like a linked list. Okay, so one is chained to the other, so you don't need all this memory together in one go. Okay, so here also, this also would be useful if you have your all the segments are of same size. Segments are of same size or similar size. But if they vary a lot, then there is a wastage. Okay, so if one segment is say 10 kb and the other is 1 kb, okay, then there is a lot of wastage of buffer, because 10 kb, okay, you will put it here, 1 kb you put here, then all the rest 9 kb would be wastage. Okay, so this is fixed size. First one and 2 are fixed size. The third is your variable sized buffer. Variable sized buffer. So here now again you can have a linked representation. Say now the segments are not of the same size, they are of different sizes. Okay, like this. So if it is a large segment, you put it in a large buffer. If it is a small segment, you put it in a small buffer. Okay, so for there will be lesser wastage in this case. However, because you have to first find out what is the size of the segment, then find a location, then find a buffer to fit it. Okay, so there is complexity. So the complexity is comparatively higher. And then you have number 4, you have circular variable sized buffer. Circular variable sized buffer. So it is something like this. Okay, so here you are putting segment 1, then next comes segment 2. Okay, then comes segment 3. Each of these segments are of different. So as the segments are coming, they are put in one by one. Okay, and say this part is still unutilized. This is free. Okay, so this is a this makes better use of memory, so there is no wastage as such. Also, the complexity is comparatively lesser than that of your regular variable size buffer. Okay, and here this it is useful if you have lots of data which is coming from if your connections are using a lot of data transfer, then this would be a better choice. So these are 4 different organizations of buffers. We can organize the buffers in this manner: fixed sized chained, variable sized chained, and variable sized circular. Okay, so why it is circular? Because as the segments are read off, they can be the space would be released. Okay, so after this, next you will be filling up here. So this is about your buffer organization. We will discuss more about buffer management in transport layer in the next video.